So this is Bjorn Ivor Teigen, head of research at Domos, recently PhD. And they have done a lot of work on latency management, but in particular, deploying applications that do it in containers on the gateway. And you're going to talk a little bit about a success story about that, right?
Indeed. Thank you very much, Jason. Yeah, that was a pretty good intro to like what Tom said is a pretty good intro to this talk, I think, because I'm going to talk about our experience of deploying our solution using USP and containerization. And yeah, so we've done this now in real life. So this is actual real life experience. So first, the agenda for this. So we have, I'll first cover the vision, and then a bit of why, and I'll cover the whys of Domos. So what are we doing and why are we doing that? And then also the whys of USP, like from an industry point of view, and from our perspective as an app developer. Then I'll talk a bit about how we do it, what the architecture looks like, how we experience the development using USP, and then some takeaways, like what has worked and what is still challenging. So this is the high-level vision, right? The ISP's home router as a platform for apps, where you can just install, like from a library or an app store, if you like, and just deploy things easily, cheaply, like build code once, run it on any platform, right? So why does ISPs want these apps? Or specifically, why do they want our app? So we know that a lot of end customers are not satisfied with their internet service provider. They don't want to pay more for like internet, and they don't want necessarily to pay for more internet in a sense. So selling bandwidth is increasingly challenging thing to do because, as many of you, I think, agree, most consumers have enough bandwidth. And so it becomes about delivering a better user experience and a more robust service that is responsive and doesn't fall down when you push it too hard. And so we're in this situation where ISPs have built enough bandwidth, but churn is high and growth is difficult. But then ISPs have these always-on computers in all of the homes of all of their customers, and that is a huge advantage potentially. And others see this as well. So Amazon is investing heavily into getting their Alexa devices deployed everywhere, right? ISPs already have those deployed. So it makes sense to start looking at ways to exploit that. And this is just the growth chart that your boss wants to see on the right. So why specifically on the home router then? Or are there any advantages to having apps on the home router as opposed to somewhere else? And we think that for some use cases, at least, the home router is a very good position, a perfect place to be, because it's the interface between the end user devices and the internet, and everything that goes into the home or out of the home goes through the home router. That gives that's a position where you can make some solutions that you really can't do, or you have to jump through a lot of hoops to get the same functionality if you're running your app somewhere else, or at least if you don't have access to that information that is available on the home router. Then there are also, of course, some issues as well. So, I mean, the home router is it's sensitive in a way because, of course, there are privacy issues. There's access to sensitive data there. That sensitive data can be leaked, and as Tom talked about as well, like malware on the home router is a really bad thing. And then there are stability issues, like deploying software written by many different teams that don't know each other and don't necessarily collaborate. Running it on the same device can cause issues unless that platform is built in a way that makes doing that safe. And those, like, if you mess that up, the cost is high because the end user could lose their connectivity, costing like, and if that's bad if it's one consumer, but if it's like a problem with the integration of apps on the platform, it can happen to a lot of users at the same time, which is obviously very expensive. And then there are integration costs. So like home routers are not or haven't been arguably they are still not an easy platform to develop for, and so there are costs associated with doing that. All right, so I'm going to talk you through what we've built and deployed. So this is what we call our network X-ray agent, which is what we're running on the home CPEs. This does a few things. So we have monitoring of network quality. So that is active and passive probing from the CPE, looking at the quality of the Wi-Fi in the home, and also the access and core network segments from the ISP. So we monitor those 24/7, and therefore we have a very good insight into how well the network is functioning. And then we do what we call application classification. So we sort apps that run on end user devices. When the traffic goes through the CPE, we classify it into like application classes. So we can say if something is gaming or video conferencing or video streaming, that at that level of granularity. So we don't say this is Teams or this is Meet or this is Netflix, but we say what kind of application it is. And the reason for doing that is because different applications have different needs from the network. So if you want to know if the network is good enough, you need to know what the end user is doing. So once we classify something as, for instance, as gaming, we compare the network requirement of a typical gaming session to the quality that we've been measuring as well. And then we can infer whether or not that gaming session it will have a good or is likely to have a good user experience, or at least we can rule out the network being the cause of any problems the user might have. If there is a problem with the app, so if we detect a game, the network is bad, then we want to know why is the network bad, right? So that's the next step, analyzing root cause analysis. That's all about pinpointing which segment is causing the problem. Is it the Wi-Fi? Is it somewhere else? And then figuring out like if it's the Wi-Fi, why is it the Wi-Fi? Is it because your neighbor is using too much of the same channel that you are on? Is it because you're on 2.4 gigahertz, but you could be on 5, that kind of thing. And then if there are issues that we can do something about, we can deploy solutions to that. So we can do things like prioritize the game on the Wi-Fi link using the QoS functionalities there. And then we also expose these things. So if you were in my talk yesterday, I talked about APIs and how we can give the applications themselves information about how the network is functioning, and also insights into these root causes and the solutions associated with those. So this is an example of the root cause analysis. So here you see, like, in this chart, 60% of cases, the quality of outcome is good and we don't have to do anything. And then in the remaining 40%, we have some kind of issue. The video conference or the game isn't working as well as it could, and it's because of the network. And then it comes down to, is it Wi-Fi? Is it access? Is it core? Or is it outside the ISP's control? And then we can break those further into like congestion, where is the congestion happening, that kind of thing. And for this specific use case, there are lots of benefits of being on the home router. So for the monitoring part, it's the only place where both the LAN and the WAN is visible. So we can know if it's an application, we know which device is using it, and we can therefore prioritize like that specific flow. For the classification, it's faster because it's local. We don't have to have a cloud that cause privacy and cost or privacy issues and add cost, right? Same thing with the next step, inferring the quality of outcome. It's just faster, easier to do it right there on the router. And then as well for the actions, it's if you want to prioritize a game, you want to detect it as fast as possible and add the prioritization right away instead of sort of waiting for a cloud solution to get back to you about that later. Right. So this, or how are we doing this, and how are we using USP to do this? So this is like the typical app high-level architecture where you have a home router, you have an app running on it natively, and then there's a cloud that it talks to. And this has some issues. So first, the integration is expensive, and if it crashes, it's like way more expensive. So that's very bad. There's been examples of data breaches associated with like sending all of this data to the cloud. So, and then of course the cloud is not for free either. So that's another cost. How does the USP help us mitigate or solve these problems? So at least one part is to use the USP agent to manage the connection to the cloud. And because that's standardized, because it's there are open source implementations of this, and it's used by many people and like a lot of developer hours and I mean resources are spent making this a good protocol and a good management system. You can remove some of the problems of having like a communication between the CPE and somewhere else. So that removes some of the privacy or the data breach risks and stuff like that. So, and if we use a single data model, that removes some of the cloud costs, because now you can leverage like the ecosystem and share data between different app developers and that kind of thing. And then if we can add containerization as well, we remove some of the risks associated with running something on the CPEs, but we don't remove all of the integration costs as well, or at least. So I haven't removed this burning money here quite yet. But so this is where I think we are today. We have an app running in a container on the CPE. It's using TR-181 and USP to send data and to manage the app and all that kind of stuff. But the integration costs are still significant. And it comes back to those things that Tom mentioned as well, where the different, and for some use cases, I think this might be less true, but at least for what we are doing, where we need to interface with the Wi-Fi drivers and stuff like that, many different platforms have different ways of doing that. It's not just that we sort of have to do the hooks and stuff like that differently between those different platforms, but the platforms the different platforms do not necessarily expose the same data, or if they do, it doesn't necessarily mean the exact same thing. So it's like it's not just like doing different hooks, but also you might have to make changes to the actual application logic, because the the data that you have access to might not be the same across platforms. So that is why I think this is like still a future vision, where we can remove a lot of the integration costs by also standardizing these low-level APIs and making it so that you can actually run, like build something for one CPE and have it run on all of them. And then this is like the next step as well. After that, where different application providers can leverage like each other's capabilities. So, for instance, as Tom mentioned, the device fingerprinting stuff that the security companies do is a useful feature that we could integrate with our solution, and that would help us make our product better as well. So having this kind of collaboration will add another level of value and reduce costs even more for this. All right. So what have we learned building this building our solution into USP and using that for and actually deploying that? It actually works. That's good. And it works. It works, and it's robust enough. It's come far enough that we can do this and deploy it in a real production environment. So it's not just a tech demo. This is actually being done at scale now, which is a significant step forward, I would say. There are some challenges. So we are a very small company, and we can like make changes quickly and stuff like that. And culture-wise, or like working with big ISPs, that is a very different way of working. So that is something that, I mean, USP can't fix that, right? But it's a challenge when you're working to deploy things on CPEs.
But if you strap that snail to a rocket.
Yes. And then I think so improvements are not always appreciated here. And it's one of the challenging things is like, even if you standardize, or maybe even kind of because you standardize, adding new stuff can be very difficult. So if once we have we collect some data on the CPE, we send it somewhere, someone else consumes that data and uses it in their dashboards or something like that, changing it suddenly becomes like a big unmanageable project, because now every dependency or everyone who uses that has to now change it if you make any changes. So what ends up happening is you just add new stuff on top and then hope eventually people will forget about the old version, which obviously takes a long time. All right, that's everything that I have for you. So thank you very much for your attention, and I'll take questions.
All right. Any questions for Bjorn? Wojciech. Hey, it's Wojciech.
Hi. So first of all, I really liked your application, because your application or presentation, because this application topic is something of a huge interest for me personally, and for Orange in general. I wanted to make one comment, because you said that the integration is still something that requires a lot of effort, and I fully agree. I wanted just to mention one thing. There are two different levels of integration, so of the problem of integration. What I like it is in your presentation is because you mentioned that basically the chipsets are not providing the same things as you would expect. And this is true if we look at, other topics, like, for example, Wi-Fi sensing. We have exactly the same problem. Okay, what the drivers provide is different on each chipset. Yeah. So definitely we have right now this problem of what the chipsets are providing. But the good news is that we only have 5 of them, and we are not discussing anymore, at least not too much, about doing specific things with every single OEM. Okay, and this is already a huge progress. So I want to say I fully agree that we still have these battles, in front of us, but there's a huge improvement already in place. So the first stage I see in resolving the problem you described is to have a common method of accessing the data. And the next one would be to standardize the data you need. Okay, so there are several steps, and of course, we are working on that. So all those that don't like those problems, please come and work on those things, because this is how we make improvements in the industry in general. So great presentation. Thank you very much. And I know that you're very active in this kind of thing. So thank you.
Yeah, thanks. That's a great comment. And yeah, I agree. It's like if we just standardize one version for all of them, yes, then that will also work. So yeah.
Yeah.
Because it's only 5, as you say. Yeah.
A quick follow-up on this, out of curiosity, when we're talking about the way chipsets provide data, are we really talking about the actual hardware, or are we talking about the driver level, or is it both? Because I mean, for the actual hardware, the silicon, those cycles, this takes time. And I mean, the Wi-Fi 7 designs, they're all carved into stone. I don't think we will see significant changes this or next year here, maybe in a wave 2 generation. But if it's on the driver level, it's a different story. Yeah, because there we can drive standardization on the actual layers we have in Linux in the low-level API, and we can try to enforce this.
Yeah, that's a very good question. I think most of it is on the driver level, and then there might be like some things that are that they just do differently, so they end up like measuring things in slightly different ways or something like that. But I think yes, by far most of it is on the driver level.
Okay, thank you so much.
You mentioned the final stage when the apps can talk to each other. And I wonder if has there been any? I mean, we're still doing this by working direct. You're still doing this by working very directly with partnerships and that kind of a thing. Do you foresee? And we probably have some anecdotal data on this, at least, just from the number of application vendors that have participated recently in Broadband Forum and in Purple Foundation, about them being willing to entertain the idea of sharing information with other applications.
Yeah, I have to say I don't know too enough, I think, about what's been proposed and what's been done so far in terms of doing that communication between the different apps. But I mean, people are very open to collaborating, so I don't see doing that collaboration through the standards as any, I don't see that as causing any issues. Right. Because yeah, at least most people here are here to collaborate. So
no, it just gets me wondering about how better we can tell that story, so that people who might have had an inkling of an idea for something, of an application that can run on the gateway, but they're like, oh, but I'm not F-Secure, so I don't have any security data. And no, I'm not, I'm not a Wi-Fi sensing vendor, so there's no way I can get Wi-Fi sensing data, to kind of tell that story a little bit. So people are like, oh, wait, I had an idea this whole time, and now I can actually do that.
Yeah, that's interesting as well. I don't, so the way I've been thinking about it is more like specific use cases where because someone has access to all the security functions and that kind of thing, they might expose like specific things that, like the device ID stuff. Yeah. Right. it's possible people will be more hesitant to expose like all of the raw data that they've collected. I don't know, but certainly for these specific use cases, it seems to make sense, because then having an app on the CPE is not just a benefit because that app adds the specific functionality that it does, but also because it, like, others can build on that. And of course, from the application developer's point of view, that makes your app more valuable and more likely to be deployed in more places. So I think there's an incentive as well to actually work towards doing that.
I certainly hope so.
Hi, Chenny of AT&T. So you already implemented this. Is it implemented on the Purple platform right now?
Purple, yes.
Yeah, yes. Okay. So so the results is more geared toward, customer support people, right? So what's your audience? You have some X-ray results. So I think that ISP, service provider, the support people want to take a look at it, right? Is any way not, say customer calling, I basically look at it, you have some suggestions, say what could be the potential problem. Can you not, because you already have an X-ray data, right? Is any like, one step further, say, oh, this could be potential problem based on customer calling some additional information.
Yeah, that is part of what our product does. Is it creates data that is then used in, for instance, customer service dashboards. But we're working with partners on that, so we don't build our own dashboards and that kind of stuff. But the data that we collect has been like the format for that has been designed in a way that makes sense to put into customer service dashboards for sure.
Right, but you got some summary, right? So basically, based on the because different, network, they have different issues, and based on customer calling, say, oh, my some Wi-Fi device is not working, and based on that information, are you going to? There's some additional feedback, right? Based on that data, now are you going to suggest something like, that could be the root cause, some root cause?
Yes, yeah. So part of what the data that we can give to customer service is like what kind of application did the end user use and at what time. So there's like a timeline, like they started a game at that time and it lasted for this long, and the quality of that gaming session was this high. And if it was, if the quality was bad, then also the root causes for why it was bad, right? So it's a yes, it does include the root cause analysis as part of that. Yeah.
Cool. Interesting. Yeah.
And the answer was, of course, that they were doing too many speed tests at the time.
Yeah. Pricing, that does happen.
Any other questions for Bjorn? Yeah.
Tim Heath from FreeCast. So I'm kind of new to this, but I'm coming from the content side, and we deal with multiple applications on multiple platforms. Do you see any challenge with creating a universal app platform with these other markets like Amazon and Google? Like you're standardizing a set language essentially for all these applications.
Yeah, I'm not sure I understand the question.
Like the applications are in the app stores right now for some of the stuff, right?
Yeah.
And they all are written with different languages, especially like Apple is different from Google, different from Amazon. So do you see a challenge with convincing them to put it all in one specific language to communicate?
So I think I can clarify a little bit on that. And it's funny because it gets me thinking about, why isn't it the case that we're just trying to use Android or something to do this, right? And it has to do with networking specifically. So I think so what's going to end up happening with this is, and I think somebody put it really well at the Purple Summit last year, was that this is going to be its own thing, right? Completely independent of Google, Amazon, all those guys. Whether or not that's an actual app store that customers interact with will be widely dependent on the time in history and the use case, right? But it's I forget who said it. It was this is not going to be millions of apps. It's going to be hundreds of apps or something. It was like kind of setting the scope of what the intention is here, right? And in the beginning, it is all going to be around the things that can be done because the router knows about them, because it is uniquely suited to doing this specific job, because it sees everything that's going on in the customer's network, everything, right? So the scope of the apps that would be created is going to be within that scope, which is obviously still within your wheelhouse. But it's not going to be a situation where we go to Google or Apple and be like, oh, now you can install Google apps on the gateway, you can install Apple apps on the gateway. Hey, can we put your stuff in your app store? Right? It's going to be its own self-contained thing that at first is targeted towards operators to decide what they want to do with it, and then maybe later have a customer-facing thing that's like, oh, I can install a Wi-Fi sensing app.
Yeah. I think as well that there is or that there are some functionality that like all apps need, like the lifecycle management stuff, like how do you install it, how do you upgrade it, how do you delete it, that kind of thing, which is there's no challenge getting all the different apps to accept those functions, right? But then of course, as the different apps do different, more specialized things in different directions, it might not make sense to like do the standardization all the way so the standard now. So the standard now encompasses every single thing that anyone could ever think of doing on the CPE. I don't know if that's necessarily where we want to end up, but for the core functionality, I mean, obviously it makes sense. And then there are also a lot of things that are common for the data models as well. Like so,
there is actually a slight problem with using something like a Google Store or Apple Store or whatever, which, as you mentioned, you need actually low-level access to the device, so it will only work in specific environments. And all of those, commonly known app stores, they're pretty much just offering over the top applications that go on an existing system. They have network access and everything, but they're pretty much running in isolation and don't have any access to the low-level data. So it has to be a different kind of store anyway, and a different kind of environment anyway, as you just mentioned, regarding the lifecycle management, etc. So there are simply some things that are not covered by those big app stores at all.
Hi, good morning, everyone. Mauro Tilocca with Team Telecom Italia. And sorry for being late in the game. I just came seeing this slide, and also I missed your baptism from Bjorn to Magnus, apparently.
Yeah, this is the wrong email again.
Magnus has become your secretary. Well, you're growing fast in the company. Anyways, so the point that I wanted to introduce with one of my jokes is, are you in brainstorming mode? Because okay, because yeah, we got time. Yeah, because you are discussing on I think a specific app and certain cases. Yesterday, you had on the other room this interaction about, okay, I'm presenting a case for checking the status of a line and coordinating with the OSS, providing remediation actions. And someone says, okay, this is going to work and produce money if the network is crappy. And you said, yes, the case ends when the network is perfect, but still it could be some amount of money. Now, getting to the point, I think that what is being done here as bars and also, side actions is also to create the ecosystem. So providing the building blocks for having something called residential gateway becoming an execution environment. And this is nothing new, but creating this as an industry mindset, and then operators marketing mindset, and then the ecosystem around goes beyond your, okay, you get money until the network is still crappy. is the key thing that is happening today. And I don't think it's a given. The given is smartphone execution environment is a great space, especially for hyperscalers to create needs. Now, what we're doing here is, doing that in the residential gateway is not a given. And the last thing I wanted to say as a stimulus and as inspiration for the people here is build the baseball field, and they will come. There are network applications, there are user experience apps that can be put there. And so this is the key thing. Another inspiration that is coming to me from the work that Broadband Forum is doing on artificial intelligence. There is the automated intelligence management suite. Because of this case of an execution environment in one of our devices, let me say, the RG, this has been also dragged as a case to say, well, there is room for opening up execution environment in other implementations like a network element. And there are companies that are saying, oh, let's do AM pipelines embedded in the node, which is, of course, opening up your implementation. So again, throwing into the storm more ideas, but I see this coming up synergically, because if, for example, that happens for a application or other applications, it's going to be great to have apps that just bring value to the food chain, also in by chunks for specific applications, thanks to the work that we're doing. Does it make any sense, Craig? At least to myself.
Yeah,
Thank you.
I think it's a very good point that there are many things that can be done on the CPEs, and if we wake up tomorrow and all the Wi-Fi networks of the world are perfect, we will find something else to do there. Yeah.
There'll be new physics. But to Mara's point reminded me of a little bit of what we were talking about yesterday, but also the fact that the applications that we're talking about, and the Domos application in particular, it's like you think of applications on the gateway and you might immediately think something that means that something it's the customer is aware of, right? But it's not the case at all, right? As a matter of fact, most of the first things in this is just getting to the point where it's super easy to add new functionality to the gateway. Now, what's important about that is it comes into our conversation yesterday about how the end user's network is a consumer electronics situation, and internet access was originally over the top. It's always been a consumer thing that came from the consumer side first. That's why the Wi-Fi industry is the way it is, right? Because it's actually consumer electronics first before it's network infrastructure second. And so there will likely be a lot of applications that are helping to turn that around a little bit as the operator does need to take more ownership of the home. The very first ones are going to be doing that, including stuff like this, right?
Yeah. Yeah, good point.
One more comment, because that's, it's about my old memory. I remember when some first rumors appeared regarding the fact that Apple was going to have an app store in the iPhone, I read an article of an analyst trying to assess how many applications there will be. And his guess was it should be around 20.
Was this Paul Krugman?
So I'm not saying that, we'll have the same amount of applications on the residential gateway. I don't think so. But I'm sure that there will be many more than what we can expect right now. So that's what I wanted to add.
But I think that's a really good point, though, because, we're dominated in the BBF by a lot of tier 1 operators. An app store or Google, and they have their one big app store. Looking at the tier 2 and the tier 3 operators, how do we work as an industry to give that common repository so that the APIs, the applications, etc., are available for the tier 2 and tier 3 operators to access and use? Maybe it's a common repository or whatever, not just the tier ones who have the buying power and resources themselves alone. And it's, you know, and then I look at the bigger picture again, or try to, and say, well, how do we do that from a service orchestration more than just a home gateway with apps sitting on it as well? We need to look at that bigger picture of how we help every service provider, not just the big guys who can be their own app store, if that makes sense.
That's a good point from like for the application side as well. Like, the sales process is like getting the app deployed is not that's a long process, getting those contracts signed, right? So making it easier for, like, I'm not saying necessarily build an app store in this like Apple or Google sense, but if you could make something that made it easy for, if we could find some way of making it easy for ISPs to try these things, and like if they like it, just have a faster way of getting that sale done, that would be also a very big benefit to the industry, I think.
Yeah, and there's also one more thing. So yes, it must enable different operators to try different things in an easy way. That's for sure. Whether it should be user facing or not, we can, you know, talk about that. But its role is also to help the application developers that have already something deployed, how to provide the upgrades, okay? Because once you are successful and this application runs in many different networks, how to streamline the upgrades, etc. So definitely that there is a lot of things that needs to be done. We had already some, I'm talking the Purple Foundation, BBF, etc. A lot of discussions about this topic. It's still, you know, just the discussions because there are more other priorities before, but this is definitely a topic of the future, how we will organize all those things between service providers, the customers, and the application providers. Everybody in this triangle needs to be happy, and it needs to work for all of them.
I just want to add something from a CPE vendor's perspective. So we are really interested in containerization of apps and things. But in the end, in our view, it's maybe more excluding stuff that is already in our firmware, like features like CARTAF server or NAS file server or something. And this is an app to make the base system more stable, and things like quality of service for video streaming or something. These are things that we are doing inside the kernel and really deep, and in parts also in hardware acceleration and something like this. And it's really difficult to give an SDK or something for a containerized application because it's not fast enough to change something there in this workflow, because often maybe we don't see even the packets that are flowing through the device. So for us, it's more something like maybe a new app for whatever, maybe a meta app or different kind of apps, in my view, maybe. Yeah.
So, you know, there is always an underlying operating system. If it exists, there's a good reason for that. Okay, so of course, some functionalities are so low level related that it's hard to imagine to put them, you know, into the application layer. So there will be always this kind of decision, what it is. Is it about the operating system, or is it about the application layer? So there's no single answer. It depends, you know, on what are the impacts regarding the technology, the hardware, and so on.
Yeah, some things will be like capabilities of the system that you could then potentially build apps on top of and use those functions, right, to do other things. Yeah,
you can always expose some level of control of your kernel implemented feature into the application layer. So you will not be able to do maybe everything.
And
but
very specifically, when John was talking about sort of the next phase of this, that's sort of what we're talking about, right? So when the applications are able to reveal TR 181 data model information to other applications, that's when you can kind of start to cross that bridge. And it's basically the entire reason why we're going in that direction, right?
So in the past, the data models were mainly about, configuring the CPE. But what I see, well, we'll discuss about it, but more and more we'll have data models that are just about controlling some functionalities of the CPE, as accessing some packets, accessing Wi-Fi sensing data, accessing data those guys may need, and so on. Okay, so the data models will be really a kind of interface enabling to deliver or to deal between the underlying operating system and the application layer.
Right. It's like, think of it as anything that you could have done with another system that has access to TR 181 information, you can do now inside building an app,
Going back to the conversation about the App Store and how it's handled, obviously one of the problems as an app developer on our end, one of the problems that we have is customer maintenance of the apps. If the service provider is the controller of what's running in the CPE, how do you envision forcing updates, notifying of updates? What does that look like whenever you're trying to keep these applications controlled? Whenever you've got a small service provider who may not be paying attention to the latest updates.
So no decision taken yet, because, it's more about the ideas than any real thing. But knowing the operators, at least the big ones, I believe that, we may enable the user to make a selection of some applications that we agree that the user can have, and then the user can make the choice. But the upgrades, etc., that will be enforced by the operator, etc., will continue taking responsibility of the firmware in the CP. It will be much more distributed responsibility because we'll work with those guys, etc. But we will not enable, will not let the things happen. Okay, it must continue being controlled, because what we want for sure is that the broadband is delivered, okay, and Wi-Fi works, and this is definitely necessary.
So just to add to that one, so to share the same perspective of you, we can help that process a little bit by being really clear and upfront about what your software lifecycle management platform is. So we're very clear with the product when we engage with the operators that, we typically we release a version, it's supported for 2 years. We have a very clear policy around major releases, which adds functionality, and then minor releases that come through the year. So, being really transparent with our partners up front about how we see that process. And then the second part is to align with the ODM on what their software lifecycle process with the operator looks like. And increasingly, we're seeing, especially bigger operators, and most operators are moving to a concept of updating the lifecycle, updating the router software at least annually. And, typically that's going to work. That's good enough. But it's making sure that everybody in that process is kind of aligned on the timeframes when it happens, and making sure that you're working together. So it requires a little bit of support from the different parties, but it is possible. We're not in a place where we were 5 years ago, where, you've just got routers out there that never get a software update. Increasingly, we're seeing the operators are actually starting to address that.
And there's also, it's possible to, like, if you can change or improve the functionality with a configuration change, then you could push that out to existing deployments without having to do actually a new installation of the new version, right? That's a workaround for some use cases, obviously not everything, but
yeah, I would add from our side, what we've seen, and this is so far still more on the set-top box side and pushing video apps. is that the service providers will kind of do campaigns to upgrade their applications on a regular basis. And that happens a lot more frequently than your firmware upgrades because it's less impacting. That continues to go towards that modularized software instead of one big firmware image.
All right. So clearly we should have done an applications roundtable. We had plenty of time, and that's where the conversation went anyway. So that's awesome. Does anyone have any other questions, comments before we move on? We're moving on earlier than base is, so this is a nice little extended break. We're going to come back right at 11 with Marcel and Volker, who are going to show us some real world. Sorry, not Marcel. Arn. No, Marcel, you are going to do it. You're going to be on the roundtable. I don't know what's going on anymore. With Marcel and Volker are going to show us some actual, real operator deployments of USP and how it's all working out. And it's going to be very exciting. In the meantime, I know Daniel is going to run downstairs real quick to take care of a couple stuff, but they're going to fire up the USP demo